Hello everyone, it's good to be back. For those of you guys who don't know, my name is Ramirez and I'm a cloud engineer at Nebulaworks. So today is the first video in a three-part series on Terraform best practices. So for today's video, we're going to be going over best practices when laying out your Terraform configuration files, and we're going to be introducing Terraform modules. So how to use them and why we should be using them. If you're watching this video, I'm assuming you guys are using Terraform already or wish to leverage Terraform for infrastructure provisioning. So if that's the case, you guys are in the right place. The takeaways for this video are these best practices are going to help you guys develop a consistent layout for your Terraform configuration files, and it's going to help you reduce duplicate code by leveraging Terraform modules. So let's move on to the objectives. So we're going to be going over Terraform configuration layout. So we're going to go over how we do that, how we lay out our Terraform code here at Nebulaworks. And then we're going to dive into an introduction to Terraform modules. So how we can leverage modules, what kind of modules we can use, and when we should be using them. As for prerequisites, I'm assuming you guys have a computer as well as the Terraform CLI, so you guys can follow along. If you guys have any questions, about any of the objectives or prerequisites, follow the links below. All right. So the remainder of this video is going to take place in the terminal, so I will see you guys soon. Hello guys, so now we're in the terminal portion of the video. So right now I'm actually in a Git repository that I made specifically for this demo, and within that repository I am in a Terraform directory. So a directory named Terraform, and inside this directory we have Terraform configuration files. Also, kind of side note, I'm going to be referring to Terraform configuration files as .tf files, a little shorter. And also guys, before we get into this, I'm going to be explaining best practices for laying out your Terraform configuration files, and then we're going to introduce modules. And the layout that I'm going to be talking to you guys about today is what we here at Nebulaworks use on the daily. So for all of our customer engagements, this is usually the layout we go with. And it's worked very, very well for us in the past, so it's a good layout. Alrighty. So I am in a directory, and this directory has .tf files. And this is a directory where a Terraform apply will be run. So the first thing you guys might notice is that I have a bunch of .tf files. And I can do this because what Terraform does is it actually aggregates all of your .tf files and it kind of concatenates them. And then it's able to create resources defined in the .tf files in the correct order. So it's able to determine dependencies. It's pretty smart. So Terraform is declarative in that sense. So the first .tf file I'm going to be talking about here is the main.tf file. So kind of similarly to a programming language, like the main function, this is usually the first .tf file that I create. And this is very important. So let's jump into it. So I'm going to just zoom here so we can take a look at it. Just make my terminal a little bigger for you guys. All right, cool. So there are two types of blocks that we have here. The first of those is a provider block. So this basically tells Terraform which provider you want to create resources in. So in this case, it is AWS. So I define a region up here, ESWS2, as well as a version. So usually version pinning our providers, just in case a newer version of the provider introduces, some form of like a breaking change or something that could give us a headache. We always want a version pin. And also, guys, just so you know, you can define multiple providers in this main.tf file. So if I wanted to create resources in Azure, GCP, I could define that as well. And Terraform is smart enough to know what provider you want to create resources in just by looking at the various resources that we define. But it's always best practice to be as explicit as possible so that anyone who's jumping into this directory knows exactly where we're creating resources and in what region. So the second block we have here is the Terraform block. So this lets us configure aspects about Terraform. So the first important key value pair we see here is the required version. So this allows us to version pin our Terraform. And so in this case, I'm version pinning Terraform to version 0.11.11. So what this is doing is it's saying, hey, if you want to run a Terraform apply with the .tf files in this directory, it has to be run with a version of Terraform 0.11.11. So this can also be a greater than or equal to, but best practices, we'd like to version pin to a specific version. And there are a couple of reasons for doing that. So the first of those reasons is that when we run a Terraform apply and that's affected, or that apply shows up in state, then the Terraform state is aware of a Terraform version now. So it basically updates itself and it expects any subsequent Terraform applies to have the same or newer version as the version of Terraform that ran the apply. So if I ran Terraform apply right now with version 0.11.11, then my Terraform state file will expect a version of 0.11.11 or newer. But that also means that if I don't version pin this and I have a team member who decides to run a Terraform apply with version 0.12 when it drops, that means that the Terraform state file is now going to expect 0.12 or newer. So this will force everyone on the team to upgrade. There is a way to downgrade or roll back to a previous version. However, it's a little complicated and it's something we usually try to avoid. So that's one reason. And the other reason is with new versions of Terraform come new changes, and those changes in new functionality could possibly break our existing Terraform configuration that we have out there, in stable environments that we don't want to change. So it's always good to run with the version of Terraform that we know works, right? We've edited it out and it works in our environments. And if we do want to upgrade, then we're going to want to test it out in a dev environment with the upgraded configuration. And if everything works, then yeah, we can roll it out to production, but always want a version pin. So the next thing we have here that we define is the backend. So Terraform allows you to store state remotely, which is always best practice. So we always want to define a backend, and we do so because we want our Terraform state to be available to all, to anyone who's collaborating with us when we're iterating on the infrastructure. If we don't define a backend and state is found locally on our computer, then our teammates can access our state. They can't modify it. So backends are best practice. So yeah, guys, that's here at Nebulaworks. That is what our main .tf files consist of, and this is always the first file that we create. So let's move on to the next one. Just click on this. All right. So the next file we're going to talk about is the variables.tf file. So I'm just going to take a quick look at that. So variables in Terraform, you can think of them as objects that store data or values. So they come in a couple different types. We have strings, lists, or maps. And basically what variables do is they allow us to parameterize our .tf files so we can pass in values to them. And this allows us to customize the resources that are defined in them, in those .tf files when we're creating resources, without actually modifying the .tf files themselves. So best practice to make use of variables, and we'd like to store all of our variables in this variables.tf file. Although not mentioned here, sometimes we do have a file called Terraform.tf vars, and that is a file that holds a little more sensitive information if we do need to pass sensitive secrets or info to our configuration. And if that is used, make sure that that is included in your .gitignore, or so that it's not pushed up to a repository. Should never have Terraform.tf var file in your repositories. So yeah, so variables are really cool, guys. Definitely make our lives easier. We could change a value in one place as opposed to multiple places. So if we hard-coded values, we'd have to change those values wherever they're located. However, variables, we just have to define a value before the variable in one place, and that change is reflected across all .tf files when you run a Terraform apply. Okay, so the next file we're going to talk about is our resource files. So these are the .tf files where we define resources. So there are actually two in this directory, so s3.tf and vpc.tf. So here at Nebulaworks, we like to split the .tf files that define our resources into logical groups. So usually they go by resource type, and oftentimes we like to have them mirror how they would look in the provider console. So in this case, we have S3 and VPC, which are resources in AWS. So we're basically mirroring the AWS console. So S3.tf is going to include or define resources that are related to S3, and the VPC.tf is going to have resources that are related to VPC, much like you would find them in the console. It just makes this a lot easier to just dive into, and you have a feel about like where everything should be located. So let's take a quick look at S3.tf. So if we go here, we can see that in this S3.tf file, we have an AWS S3 bucket defined. So we're going to call it flow logs. And we can see here that we are making use of our environment variable, var.env. So depending on what environment this is running from, a new bucket is going to be created. And we can see here we also have environment specific tags. And we can do this because we are using the env variable. And this Terraform.workspace value here shows you, or I guess it tells you what workspace the Terraform apply is being run in. So in this case, it's going to default to the default workspace, but this becomes very handy when you're collaborating in a team and you're creating resources specific to your workspace. So this makes our lives easier when we're looking at resources in the console and just trying to figure out who created what. Cool. So let's take a quick look at the vpc.tf. And as expected, we have a VPC-related resource here. It's an AWS flow log. So the logging destination, if you see here, oops, sorry guys, is going to be that AWS S3 bucket that we created in the s3.tf file. And here's a quick example of implicitly defining dependencies between resources. Because I'm referring to an attribute from a resource I'm defining in another file, then Terraform expects this bucket to be created first before it creates this flow log. So that's just something good to know. So we also see that we're providing a VPC ID, and this is going to be a VPC that we create with the VPC module. So we're going to talk about that in a sec. But yeah, guys, that's how we define our resources. We definitely like to separate them into resource types. Definitely makes things more visible. It's definitely better to kind of know where a resource should be located than having to grep or search through like a 500-line main.tf file. Coolio. So the next file we're going to be taking a look at is the outputs.tf file. So let me just open that up. So outputs outputs allow us to output information about resources created in our .tf files. So they're usually something important information that would make our lives easier. Say I'm creating a Route 53 record in Terraform. Let's say I want to be able to visit the site that's using that record as soon as a Terraform apply is run. If I define an output for that, I can easily just copy paste it into my browser because it shows right after a Terraform apply. But more importantly, outputs allow resource attributes to be accessible by the outside world. And the outside world in this case would mean another module that's referencing this directory or the .tf files in this directory. So we're going to talk about modules in a sec. But yeah, so outputs, very important, and we always want to define outputs for information that we want to make available to other modules. Cool. So let's go to modules. We're going to take a quick look at this module.tf file. So a module, actually, before we get into that, I'm just going to say that this is where we define our module blocks. So we create a module block every time we want to reference a module. And this module.tf file is going to have all the module blocks that we define. So if we are utilizing modules, I'm going to expect to find them in this module.tf file. We're going to be getting into modules in a sec, so I'll just leave it at that for now. Cool. And that's about it, guys. So that is how we define our .tf files, or how we lay them out here at Nebulaworks. It's worked very well for us, and all of our engineers basically create directories in this fashion. So hopefully this has inspired you guys to come up with your own layout or something that works for you. But I guess the thing to take away from this is that whatever layout you do come up with, you have to make sure that it's consistent and that you are utilizing it on all projects, in all your repos, and that all team members are on board with it. So yeah, cool. All right, so now let's move on to modules. So when it comes down to it, a module is just a directory with .tf files inside it. And these .tf files are usually related resources. So let's say, for example, let's say I want to create a VPC. So if I want to create a VPC with Terraform, I'm going to have some .tf files that define resources that are related to VPC. So they could be resources like an internet gateway, public-private subnets, routing tables, NAT gateways, things like that. And basically, all these resources come together to create a functional VPC. So that's cool, right? Like, have my VPC defined in Terraform configuration. It's good. I can deploy it. Terraform apply. I have a VPC. So the cool thing is these .tf files can be reused over and over again. And that is what a module is. It's basically a package of .tf files that are reusable. Kind of similar to a function in programming. We're going to provide inputs to this module. So those inputs come in the form of like variables, input variables. The module takes those variables, customizes the resources that are defined in the module, and then spits out outputs. So I could have that VPC module or that directory with Terraform files that define resources for a VPC module. And every time I want to create a VPC, I can just point at it and say, hey, if I run Terraform apply, I'm going to use this directory to create my VPC. So modules are pretty cool. And there are actually two types of modules. The first is an internal module. And basically what an internal module is it's a module or directory that's located within the same repository. So I'm going to show you guys this right here. Actually, let me take a quick step back. Before we discuss the types of modules, I'm going to kind of reiterate that we define a module block where we give it a name. So module in this case is VPC. And then we define a source. So a source basically provides a path to the module. Yep, cool. Now we're back on track. So I mentioned that internal module, which points at a directory that's within the same Git repo. So in this case, this directory or this module, this VPC module, would be a couple of directories up and one down. So we would just define the source as a file path. So I'm going to take that out here. So now that we know that's an internal module. So there are also external modules. So these are modules or directories that are not located within the same Git repository. And there are three main types that we'll see. The first of those, which is like this top source, key value pair, is the Terraform public registry. So HashiCorp has a public Terraform module registry, which are basically created by the community and vetted out. So if you want to make use of modules, that's probably the first place to look. So it usually has this syntax. It's basically the name, the module, and the provider. So we're going to keep that here. Next, we have Git URLs. So in this case, this is a link to a GitHub repository. And yeah, it's pointing at an external repository. If you guys notice here, I am referencing a specific release version. So, like most things that you've seen so far, we definitely want to version pin our modules. So we do this because, they're constantly being iterated on, and, improvements are made. And with improvements, sometimes bugs pop up. And we always want to be, leveraging a version of the module that we trust and that we know works. So that's why we're kind of referencing a specific release here. So yeah, that's a get URL. And lastly, you can also reference Terraform configuration or a module that is stored in S3. So that's not as popular, but you can do it that way as well. So I'm going to get rid of this source here. Cool. And just to clarify, guys, I had multiple sources defined just so I could show you the different types. But usually in a module, you're always going to want to have a single source. So in this case, this module block that I'm defining is leveraging the VPC AWS module that's part of the Terraform module registry. And as you can see here, I'm also version pinning the module. So in this case, this module is referencing the 1.60 version. Cool. So let's take a quick look at these inputs. So you can see that this module takes a couple of inputs. So those being the name, the CIDR block, the availability zones, as well as private public subnets, and whether you want NAT gateways in there. So we provide custom values for these inputs. So in this case, I'm naming my VPC, a specific name. I can define the CIDR block. I can also define, what availability zones I'd like to use, as well as how I want to segment my subnets. And basically what the module does, it'll take these inputs and then it will place them in variables. And those variables will then, pass those values into the .tf files. So now we're creating a VPC with this module that has our customized values. And if I wanted to, take, say, an output or, take reference attribute information from the resources that are created in this module, then I can reference them like so. As you can see here, this VPC ID that I'm passing into the flow log resource is basically the VPC ID of the VPC that's created with the module. So you can reference outputs by defining the module block, or the module block name, and then the output name. So you guys, that's like a quick introduction to modules. Definitely make our life easier, and is definitely a best practice to use them when necessary. They get rid of a lot of duplicate code, and code reuse is always good. So that's it for the terminal portion of this video. Thanks for watching, guys. I look forward to seeing you in my next video, where I'll be discussing directory structure best practices, and we're going to be taking a deeper dive into Terraform modules. So if you guys enjoyed this video, please like and subscribe to our channel. And if you guys have any other questions about Terraform or any of the other HashiCorp tools, please visit this link. Look forward to seeing you guys soon.